Google Cloud Dataflow, it's a fully managed data processing service. What is Dataflow? Dataflow is Google Cloud's fully managed data processing (ETL) service. Process massive batch and streaming data as per user need. Automated provisioning and management of processing resources. Distributed parallel processing using Apache Beam SDK. Horizontal auto-scaling of worker nodes based on workload. Jobs are billed per second based on the actual use of Dataflow batch or streaming workers. Why Dataflow? Users can focus on programming instead of servers and clusters. Fully dedicated to transforming and enriching data in stream, real-time, and batch, historical, modes. Can be easily integrated with various other GCP services like BigQuery, Cloud SQL, Bigtable, GCS, logging, PubSub, etc. It aims to address performance issues when building pipelines to processing huge amount of data, example, MapReduce performance issues. Pipeline coding model is pretty straightforward, Apache Beam SDK supported by different programming languages. Data encryption by default and efficient access control mechanism. Let's compare Dataflow vs Hadoop Spark vs traditional ETL. Dataflow fully managed and can scale automatically based on size of data being processed, whereas Spark needed cluster management and administration efforts. Spark has its roots leading back to the MapReduce model, which allowed massive scalability in its clusters. Its central concept is the Resilient Distributed Dataset, RDD, which is a read-only multi-set of elements. Dataflow's model is Apache Beam that brings a unified solution for streamed and batch data. Concept is based on peer collection and p-transform. Traditional ETL tools are mostly needed infra management, might not suited for really massive datasets to process. Here is an example of data processing application where Dataflow fits in. If we see this architecture diagram, there are two branches of data processing methods used. Lower branch is to process batch data coming from mobile app in frequent intervals. Upper branch is to process stream data coming from mobile app for real-time analytics. Here we are using PubSub as messaging service in both use cases. Google Cloud Dataflow is the go-to service to process both batch and streaming data. Here the term process applicable for extract, transform, load, ETL. Process data is being loaded to BigQuery for further analytics. It can be used for batch and real-time reporting, or can be exported to spreadsheets, or can be used for interactive user analytics using SQL. Let's see Dataflow integration with other GCP services. Dataflow can integrate with different sources and sinks available on GCP. Here we need to understand few terms before we proceed further. Source means from where data extracted for further processing. Sink means to which the process date is written or loaded. Dataflow can be integrated with almost all Google Cloud Data Stack services like BigQuery, PubSub, Cloud Storage, Bigtable, Cloud SQL, etc. Let's see how to access Dataflow using required IAM permissions and roles. Dataflow required roles and permissions are managed by identity and access management. Permissions can be granted to individual users or groups or service accounts. These are the IAM roles and permissions required. Dataflow admin, minimal role for creating and managing Dataflow jobs. Dataflow developer provides the permissions necessary to execute and manipulate Dataflow jobs. Dataflow Viewer provides read-only access to all Dataflow-related resources. Dataflow Worker provides the permissions necessary for a compute engine service account to execute work units for a Dataflow pipeline. How Dataflow pricing or cost is calculated. Each Dataflow job uses at least one Dataflow worker. The Dataflow service provides two worker types, batch and streaming. Batch and streaming workers have separate service charges. Dataflow workers consume the following resources, each billed on a per-second basis. The CPU, memory, storage, GPU is optional by the way. How to interact with Dataflow. There are two options available. We can use Web Console to submit and monitor the Dataflow jobs. Other option is by using command line tools like Cloud Shell to submit and monitor jobs. Now, let's talk about Apache Beam programming model for creating pipelines. Apache Beam is a unified programming model for both batch and stream processing. Apache Beam abstraction layer allows it to be created in any language like Java, Python, Go, etc. and can be executed on any execution framework like Google Cloud Dataflow, Spark, Flink, etc. Apache Beam, SDK and supported programming languages. Dataflow pipelines can be created by using Apache Beam's SDK. Write the pipeline in your choice of programming language SDKs, Java, Python or Go, Beam SQL, etc. and deploy your pipelines to run on Dataflow environment. Let's examine Apache Beam basic components of pipeline abstraction. Pipeline, it encapsulates the data processing tasks from start to end, which includes reading input data, transforming and writing output data. P-collection, a distributed dataset on which Beam pipeline operates. It can be either bounded or unbounded. It is immutable in nature and thus, any transformation on P-collection will create a new P-collection. P-transform, it represents data processing operations or transformation steps that are applied on P collection. Sink and sources, the source and sink APIs provide functions to read data into or write out of P collections. Let's understand Apache Beam pipeline and its components in association with its programming model. Pipeline execution starts with input data extracted from source into a P collection. Here in the diagram, P collections are shown in circles. Next step would be to apply single or series of transformations on top of raw P collection and produce intermediate or output P collections. In last step, output P collection can be written into a target or sink. Let's quickly go through important Apache Beam, core Beam transformations. Pardo, Beam transform for generic parallel processing. Group by key, Beam transform for processing collections of key value pairs. Co-group by key performs a relational join of two or more key value. Combine, Beam transform for combining collections of elements or values in your data. Flatten, Beam transform for P collection objects that store the same data type. Flatten merges multiple P collection objects into a single logical P collection. Partition, Beam transform for P collection objects that store the same data type. Partition splits a single P collection into a fixed number of smaller collections. Where do you code, test and deploy your Apache Beam pipelines? You can do pipeline coding in Cloud Shell or Python IDE. If you are using any other programming language other than Python, use corresponding IDE. Test pipeline locally with Direct Runner on Cloud Shell, which can be used as local environment to test the pipeline with Direct Runner option. Once testing is successful, deploy and run your pipeline on Dataflow environment using Dataflow Runner option. These are some common use cases of Dataflow usage. Batch data processing use cases. Example, log data processing, all common ETL use cases in case of large datasets processing in distributed parallel processing environment without infra management. Stream data processing use cases. Example, processing sensor or GPS data for real-time analytics. Real-time AI, for anomaly detection, pattern recognition and predictive forecasting. These are few, but we can consider Dataflow for many other use cases. Now let's see Dataflow in action. In this demo, we will see a simple use case, design and implement a Apache Beam pipeline using Python SDK and run this pipeline on Dataflow environment. Here are the pipeline steps. Step 1, read data from CSV or sheet available in Google Cloud Storage. Step 2, transform and aggregate data. Step 3, insert resultant data to a BigQuery table and examine the output data. Now let's check the demo now. Examine the input data here. We have our input CSV file is already placed in GCS bucket. Our Apache Beam pipeline is going to read data from this source. Our Beam pipeline code is going to read data from file placed in GCS bucket, perform very simple transformations like rearrange the data and extract required columns from input data, and finally aggregate and write the output data into a BigQuery table. Here is the CLI commands which we are going to use to deploy this Beam pipeline on Dataflow environment. We can refer GCP official documentations for CLI commands for better understanding. Now, let's quickly examine our Apache Beam pipeline, which is coded using Python SDK. We can choose other programming SDKs as per our choice and requirements. Here we are importing required dependent Python libraries which would help Beam pipeline to perform defined data processing actions. This code is to perform user-defined transformations like data cleanup, rearranged through Pardo, which is distributed parallel processing in nature. This code is to read input data from source using command line arguments. Once input data is available in P collection, we are performing series of data cleanup and aggregate steps using predefined and Pardo transformations. Finally, once cleaned and aggregated data is available in output P collection, write data into a BigQuery table using this step. Once your Beam pipeline testing is successful, deploy your pipeline using CLI commands for Cloud Shell environment. Here we are deploying our pipeline onto Dataflow environment. Once pipeline is deployed, we can monitor the same on Dataflow's console page here. Explore different options available in this page. For more details, click on Job ID, which would take you to more details page and graphical representation of our deployed pipeline. Explore other options in this page. After few minutes, pipeline getting completed. Now it's time to verify your output data. Go BigQuery Web UI and click on table name mentioned in pipeline output transformation, verify table metadata details, and click on preview for viewing your process data, which can be further used for different purposes. I know it is quite a long time I am not actively uploading videos onto our channel. Due to some personal commitments, I didn't get time to spend and upload videos. I hope you will understand. This is a quick complete guide of Dataflow. We have pretty much covered all important topics here. I hope this video finds you well and encourage you to explore Dataflow in detail. I will continue to do this kind of complete quick guide videos on other GCP services as well. Your encouragement is a real motivation for me. Please do share, subscribe. Happy learning!